Here, I'm going to give you guys a basic introduction on how we are going to evaluate limits algebraically, and we'll go over 8 examples. Here's the first one. We have the limit as h approaching 0. So, whenever we have that, we should always plug in this number into the variable first. So we have 5 plus 0 squared plus 2 times 5 plus 0 minus 35 over 0. On the top, this is going to give us 25, and then this is going to give us 10, and then minus 35, and then over 0. And that's just going to be 0 over 0. Well, if we have 0 over 0 when we do limits, this is an indeterminate form, meaning we cannot draw any conclusion yet. We will have to do more work. So, what do we do though? Here is the algebra that we will have to go through. Right here, we still have the limit as h approaching 0. Let's go ahead and expand the 5 plus h squared, which will just get 5 squared, that's 25, plus 2 times this and that, which will give us 10h, and then plus h squared. Then we are going to distribute the 2, so we will have plus 10 plus 2h, and then minus 35. Now have a look. We have 25 plus 10, which is 35, minus 35. So all three together is just 0. They cancel each other out, right? And then we will have this. Here, 10h plus 2h, that is just 12h. And then we can factor out the h. So this is going to be the limit, h approaching 0. Factoring out the h, we have 12 plus h. And as you can see here, we can cancel out the h. In fact, when we have h approaching 0, and if this was a 0 over situation, then we should be able to cancel the h on the bottom. After that, we plug in 0 into the remaining h and see what do we get. So here we will just have 12 plus 0, and the answer is just equal to 12. And that will be the answer for this limit. And that's it. Now, let's look at the next one. Here, when we plug in 1 into all the x's, this is 1 plus 5 is just 6, minus 6, we get 0. On the bottom, 1 minus 3, which is negative 2, plus 2, we also get 0. So here we have another 0 over 0 situation, and this is what we can do. We have the limit as x approaching 1 now. On the top, we have a quadratic. We can factor it. So let's see. X times x will give us x squared. And think about two numbers that they multiply to be negative 6. Together, they add up to be positive 5. And the correct combination will be plus 6 and minus 1. On the bottom, x and x. Two numbers multiply to be positive 2. Together, they add up to be negative 3. We need negative 1 and negative 2. Now have a look. The x minus 1 cancel each other out, right? And here is the hint for you guys. When we have x approaching 1, if it was a 0 over 0 situation, then we can always expect to cancel out the x minus 1 factor. Keep this in mind, it's going to be really useful later on. And we just did. The x minus 1 got cancelled. Then we will just have to plug in 1 into the remaining x's. So we will have 1 plus 6 over 1 minus 2. And that's just going to be 7 over negative 1, and the answer is just negative 7, and we are done. Okay, next one. The limit as x approaching 2. Yes, the top can be factored in, but we don't have to do that because when we have 2 to the third power minus 8 over 2 times 2 plus 5, the top right here is 2 to the third power is 8 minus 8, we have 0. The bottom here is going to be 4 plus 5, which is 9. So what's 0 over 9? The answer for this is just equal to 0. We get to draw a conclusion. So the answer for this limit is just equal to 0. Done. This is it. Okay, here we have a square root case. Still plugging 3 into all the x's. So we are looking at square root of 3 plus 1 minus 2 over 3 minus 3. This is square root of 4, which is 2. And then as you can see, we have 0 over 0, right? Therefore, we will have to do more work. Cannot draw any conclusion yet, all right? Now, here's the key. Remember how I told you guys earlier, when we have x approaching 3, x approaching a finite number, and it was a 0 over 0 case, right? So what factor can we expect to cancel? Yes, you can just kind of move the 3 to the other side. We can factor and cancel out x minus 3 later on. You will see that will happen. Trust me. But how do we take care of the square root situation though? The key is to use the conjugate. We are going to multiply the top and bottom, and make sure you put down parentheses first before you multiply. The conjugate of the top is just square root of x plus 1, and we are going to change the minus to a plus. And then we do the same thing on the bottom. All right, so here we have the limit as x approaching 3. On the top, just go ahead and multiply it out. And the easy way to do it is just, we have the a minus b times a plus b. We just end up with a squared minus b squared formula. So just go ahead and square the first term. Minus square of the second term, which is just a 2. And for the bottom, do not multiply it out. Just leave it. Now for the top though, we see that square root cancel. So we have this. It's just x plus 1. And then 2 squared is just 4. So minus 4 right here. And again, leave the bottom. Okay, on the top, we have x plus 1 and then minus 4, right? So of course, that's just x minus 3, and then we still have the bottom. And as we can see, as I told you, and it's happening right now, x minus 3 cancel each other out, right? Then we can plug in this 3 into the remaining x and then see what happens. On the top, we still have a 1. And on the bottom, we have square root 3 for the x, and then plus 1, and then plus 2. So that's going to be what? This is just square root of 4, which is just a 2. 2 plus 2, right? So we just have 1 over 4. And that's the answer. Done. Now, let's take a look at a complex fraction situation or compound fraction situation. It just means that we have a small fraction, another one inside of a big one. But still, we should plug in this number into all the x's and see what happens. We have 2 over 4 plus 2 minus 1/3 over 4 minus 4. This right here is 2 over 6, which is just 1/3, and then minus 1/3 over 4 minus 4. Yes, we have 0 over 0, as you can expect it, right? So how are we going to take up this situation now? The key when we are trying to simplify a complex fraction is to multiply the top and bottom by the lowest common denominator of the small fractions. We have x plus 2 and 3, and these two are what we need. So x plus 2 times 3. So we will have the limit as x approaching 4. On the bottom, don't multiply it out. Perhaps let's just write this down first. Put the 3 in the front, and then x minus 4, and then x plus 2. On the top, take this, multiply with the first term, the x plus 2 will cancel, and we will have to do 2 times 3. And let me just write that down right here, 2 times 3. Then we will take this times that. In this case, the 3 will cancel. So we will have minus 1 times x plus 2. Now, here's a very common mistake when people do this kind of questions. Notice that we have the x plus 2 right here, right? But do not cancel them out. Do not cancel them out. And the reason for that is because here at the top, notice we have the minus here. We will have to work it out, combine terms on the top before we can cancel anything. And another thing is that, remember I told you, when we have x approaching a finite number, here we have x approaching 4, right? And it was a 0 over 0 situation. So we can expect to cancel what? Put the 4 to the other side, x minus 4. This is the factor that we should be able to cancel out later on. You will see that will happen. Trust me. Now, let's focus on this. Here we have the limit as x approaching 4. 2 times 3 is 6. And then distribute the negative. So that's negative x minus 2. For the bottom, just keep it. And for the top now here, we can just do 6 minus 2, which is 4. So we have the limit as x approaching 4. And you should be writing down the limit as x approaching whatever number every single step, all right? Okay, 4 minus x over the denominator. Okay, on the top we have x minus 4. On the bottom we have, well, on the top we have 4 minus x. On the bottom we have x minus 4. We cannot cancel out them. They are not exactly the same yet. But this is what we can do. Note that when we have 4 minus x, we can rewrite it as negative, and then we change the order of the subtraction. Like this. Why? Because if you were going to distribute this, you will get negative x plus 4, which is the same as 4 minus x. So when you have 4 minus x, like we want to have the x going first, you can switch the order of subtraction by just negate the result. And that's exactly what we'll be doing right here. So still the limit as x approaching 4. On the top is minus x minus 4. And then the bottom we have this. Now what can we cancel? Yes, we can cancel the x minus 4 as what I told you earlier, right? Now let's just go ahead and plug in 4 into the remaining x. So we have negative 1 on the top over 3 times, we want the 4 to be right here, and then plus 2. So that's negative 1 over 3 times 6, which is 18. And that is going to be it. That's the answer. Okay, another complex fraction case. And in this case, you will get 0 over 0. Okay, you can go ahead and try it. Now let's go ahead and multiply by the lowest common denominator of 2x and 10. Notice this is 2 times x and 10, right? So we just need 10x because the lowest common multiple for 2 and 10 is just 10. So let's just multiply 10x, it's enough. And also do the same on the bottom. Now, if you take 10x, multiply with the first term, let's see what we have. Well, that's just going to be 10x over 2x, right? The x cancel, and you see 10 over 2 is just equal to 5. So the first part is just equal to 5. Next, take 10x times 1 over 10. Well, 10x over 10, that's just going to be x. So on the top we have 5 minus x. And then for the bottom, we are just going to leave it. Put the 10x first though, and then x minus 5. Well, here we have 5 minus x on the top. Don't worry. We can do the same thing like what we did in the previous question. So here, factor out negative and then change the order of the subtraction. And then the bottom stays the same. Aha, we have x approaching 5. Here we see that x minus 5 is going to be cancelled, just like that. Then we can just go ahead and plug in the 5 into the x. So negative 1 over 10 times the 5. And notice whenever we plug in the 5 into the x, no more LIM, no more limit, right? Because we are going to get the answer already. And in this case, we get negative 1 over 50, and that is the answer. And then we're done. Okay, next one. We have the limit x approaching 6. So if you haven't noticed already, yes, we have the limit as x approaching 0, x approaching 1, 2, 3, 4, 5, and right now we're up to 6. Anyways, though, for this one, you will get 0 over 0. I promise you that. So what do? Well, on the bottom, we can factor it. So let's do that. This is x squared minus 36. We can factor it as x minus 6 times x plus 6. On the top, we have x minus 6 squared. Let me write it down twice. And then as you can see, we can cancel with one of the x minus 6. Then we are going to be plugging 6 into all the x's. So this is equal to 6 for the x, and then minus the 6 over 6 for the x, and then plus the 6. The top is 0, the bottom is 12. Altogether, we get 0. 0 over a finite number, we get 0. Done. Okay, let's do one more. Here, we have a square root case. Are we going to get 0 over 0? You bet. Because otherwise, there's no practice, there's no challenge, right? Anyways, what do we do with the square root case? The conjugate, yes. So multiply the top by square root of 2x minus 5, but here it's a plus 3. And do the same thing on the bottom as well. Okay, so here we have the limit as x approaching 7. On the bottom, just leave it. On the top, multiply it out. A minus b times a plus b, we just get a squared minus b squared. So we square the first term. And then minus square the second term. So square cancel, square root cancel, and then we will have the limit as x approaching 7. On the top, we have 2x, not 25. I mean 2x minus 5, and then 3 squared is 9, so minus 9, and we have the rest. Okay, keep going with the top. Let me just indicate that right here. That's just 2x minus 14, and we can factor out 2. So for the top, it's just 2 times x minus 7. And then the bottom stays the same. And then as you can see, we can cancel the x minus 7. Very nice, right? And then finally, plugging 7 into the x. So this is, whoops, no more limit, because when we plug in for the answer, no more limit. So 2 over square root 2 times the x, which is 7. And then minus 5, and then plus 3. So the top is 2, the bottom is, okay, 2 times 7 is 14, and then minus 5 is 9. So square root of 9, and then plus the 3. So that's 2 over 3 plus 3, which is 6. So the final answer is 1/3. And that's it.